Hi, everybody. We are back with day 2 of stats. We're going to be comparing and contrasting observational studies today and experiments. So, in lesson 1, we learned about sample surveys or methods to choose a sample. So a good sample survey always has randomness and it eliminates bias. Okay, so those are all like we talked about a little bit yesterday, right? We want to eliminate bias to produce data that will allow us to make claims and predictions about the population. There are two ways to gather data for your statistical analyses. It's either observational studies or experiments, okay? And randomness, which we've talked about, plays a role in these methods as well. So, very important you know the difference between an observational study and an experiment. An observational study literally just observes, okay? An observational study observes individuals and measures variables of interest, but does not attempt to influence the response. So data is collected, but nothing is influenced by the researcher. Literally, look but no, don't touch, or no treatment. Where an experiment deliberately imposes some treatment on the individuals to measure their responses. In an experiment, the researcher has a control of the variables of interest. So look and touch. There is treatment. There is treatment in an experiment. So I know these are like kind of silly pictures, but the guy on the left is Captain Observational Study. He's got his clipboard, he's got his cape, but he is literally just going to watch what they are doing. He is not going to do anything. Don't touch. Where the other two, these two are doing an experiment. She's doing some type of major science mixing potions, and he is helping. I guess I shouldn't say potions. Whatever you guys mix in chemistry, you're all in chem. Okay, so just notice in the experiment, you're actually doing something, where in the observational study, you are literally just watching. Okay, so before we even go further, the most important thing is you being able to tell, is it an observational study or is it an experiment? The most important thing is to look to see if the researcher is or is not imposing treatment. Okay, it's all about imposing treatment. If they're imposing treatment, it's an experiment. If they're not imposing treatment, it's an observational study. So, ask yourself, are they doing something to the people in this study? If yes, then it's an experiment. If no, it's an observational study. Okay, so does reducing screen brightness increase battery life in a laptop computer? To find out, researchers obtained 30 new laptops of the same brand. They chose 15 of the computers at random and adjusted their screens to the brightness setting. The other 15 laptop screens were left at the default setting, moderate brightness. Researchers then measured how long each of the sorry, I lost my thing. Researchers then where did I go? Researchers then measured how long each machine's battery life lasted. Was this an observational or an experimental study? So what are you guys thinking? Was their treatment imposed? Yeah, right? What happened? They adjusted their screens to the brightness setting. Okay, they took it and adjusted, and the other one just had moderate brightness. They left it at a default setting. So this is no doubt an experiment. I would say the researchers imposed a treatment in this case, screen brightness. Okay. All right, let's talk about example 2. Does eating dinner with their families improve students' academic performance? According to ABC News article, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey conducted by researchers at Columbia. Okay, so here the thing is, it's a sample survey. Was this an observational study or an experiment? It's an observational study. No treatment was imposed. The researchers simply used the results of the sample survey. Okay, so I would say immediately this is an observational study. No treatment was imposed. The researchers simply used the results of the sample survey. Okay? Okay, so let's keep going. So anything like surveys, questionnaires, online polls, like a Twitter poll, researching available data from sources, and a guy with a clipboard is going to tell you it's an observational study. So sample surveys are a type of observational study. Now just take note of this little sentence here. It says, I'm just going to put a little story here. So all sample surveys are observational studies, but not all observational studies are sample surveys. So you don't always have to have an observational study that came from a sample survey, but if you're doing a sample survey, it's definitely an observational study. So observational studies do not allow us to show causation or cause and effect relationships. When subjects are selected blank, we are able to use the data from an observational study to make claims about the population. When the subjects are selected randomly, right, without bias. So observational studies are great for describing a specific group, comparing groups, or examining relationship patterns between variables. Okay, so let's take a look at example 3. So this one's interesting. So example 3 says, consider the multiple choice below, but don't answer yet. So I'm going to read all the situations to you. It says, which scenario describes an observational study that is not a sample survey? So you want the one that isn't a sample survey. Okay. So number 1 says, for a class project, students in health class ask every 10th student entering the school if they eat breakfast in the morning. Number 2 says, a social researcher wants to learn whether or not there is a link between attendance and grades. So she gathers data from 15 school districts. Number 3 says, a researcher wants to learn whether or not there is a link between children's daily amount of physical activity and their overall energy level. So during lunch at a local high school, she distributed a short questionnaire to the students in the cafeteria. Number 4 says, 60 seniors taking a course in advanced algebra concepts are randomly divided into 2 classes. One class uses a graphing calculator all the time, while the other class never uses the graphing calculators. A guidance counselor wants to determine whether there is a link between graphing calculator use and a student's final exam grades. Okay, so first question, I guess we should try to answer which one is an observational study that is not a sample survey. And just one of them crazy sticks out to me. And you see the bottom part, it says, circle the option of data collection that best describes the choices from above. One of them to me is not like the other. Does anybody know which one isn't even an observational study? Okay, so I'm hoping you're going to say 4. 4 this is an experiment. Okay, so I am going to immediately circle choice 4 could never be an observational study. It's an experiment. You're dividing and you're imposing some type of treatment. Half the class is going to have calculators while the other half is not, and then you're going to see if there's a link between the calculator use and the final exam grade. Okay, so let's look at the other 3. So for a class project, students in health class ask every 10th student entering the school if they eat breakfast in the morning. Is that an observational study? Yes. But is it a sample survey? Yes. This is no doubt one. They're literally asking kids as they come in, asking every 10th student. So it is an observational study, but it is a sample survey. In number 2, a social researcher wants to learn whether or not there's a link between, but she gathers data. So no survey was used. Here's your observational study. This has to be your answer. So I just want you to make a little note that no survey was used, right? No survey was used to collect your data. Now let's just look at 3. A researcher wants to learn link between physical activity. So they distribute a short questionnaire. Done. That's going to be another sample survey. Okay, does everybody understand that? So even though those first 3 are observational studies, an observational study doesn't always have to be a sample survey. Okay, numbers 1 and 3 were sample surveys, where number 2 was not. Okay. So now we're going to start talking a little bit more about an experiment. And again, here's just a lot of information for you. So an experiment is the only way to establish cause and effect relationship. So again, experiment, cause and effect relationship between these 2 variables. Experiments are a great way of examining your relationship between the 2 variables. In an experiment, you have control over the variables of interest, and if you observe significant difference, you know it had to be caused by the treatment you imposed. So you have the control. A well-designed experiment uses randomization to assign subjects to different groups, and this also helps groups as similar as possible and eliminate bias. So you do not want bias. Randomization eliminates bias when you randomly select. Again, like, you don't stand in front of Yankee Stadium and ask people their favorite team. Okay, that would be bias. It has to be more random. In a very simple controlled experiment, you would have 2 groups, and at the end of the experiment, you compare the results of the 2 groups. Now, the 2 groups are usually your control group and your experimental group. So the control group, aka the placebo, receives some type of dummy treatment or placebo where they don't receive anything at all. And this usually serves as your baseline, where the experimental group receives treatment. So like, they would get the drug, they wouldn't get the placebo. And this group we hope to observe a change in. So all experiments do not necessarily have to have a control group, but many experiments examine more than one variable, and they have multiple treatments. These are just some ways to design an experiment. Okay, so take a look at number 4. So in number 4, it says a professor is interested in whether giving a practice exam has an impact on the performance of students on their final exam. So the professor has a class of 60 students. Okay. He randomly selects 30 of them, so half the class, to receive no practice exam. The other 30 receive a practice exam, and at the end of the study, the exam results are compared. So he randomly assigns group 1 gets treatment A, which is no practice exam, compares, where group 2, 30 students, gets treatment B, gets a practice exam, and we compare. Okay, so which treatment was given to the control group? So who is the control group? The control group is the group that nothing happens to, right? Okay, control group is like the placebo. They don't receive treatment at all. So that is treatment A. Okay, I would say treatment A, and that was no practice exam. Okay, which treatment was given to the experimental group? Well, the experimental group was clearly treatment B, and treatment B had the practice exam. Okay, so there's your two different. So it says at the end of the experiment, the means for the two groups were, so your mean for group 1 was 75.5, and your mean for group 2 was 82.3. And they say find the mean of group 2 minus the mean of group 1. So 82.3 minus 75.5, which gives you 6.8. And 6.8 we literally call the difference of the means. Okay, so the professor was not surprised by these results. Explain why he might think this way. So what are we thinking? What are we expecting? Why is he not surprised? Which group had the higher mean, right? Group B or group 2 had the higher mean. So we expect the practice exam group to, as a teacher, I would expect the practice exam group to score better on an exam, producing a more positive outlook, right? Or more positive difference. It is expected that the practice exam should help the students score better on the exam. Okay? So I am going to say we expect that a practice exam should help students score better on the exam. I'm thinking if we give you guys some type of practice test and you're seeing that information later on when you take the ending exam, right? A pre-test and a post-test, you're going to do better. Okay. So it will eventually be our goal in stats to determine if the difference that we observed, okay, so this is like really nice foreshadowing to what you're going to be seeing, that the difference that we observed, is it large enough to make a claim that it couldn't have happened by chance alone. If that is true, this means that something is likely happening in our study. This is the beginning of the idea of statistical significance. That's going to play a really big part later on in stats. Okay, so let's talk about example 5. So in example 5, it says, describe how a controlled experiment can be created to examine the effect of a whitening ingredient X in a brand of toothpaste. Okay, so that's pretty easy, right? How can we describe a controlled experiment? Well, a group of people are randomly divided into two groups. One group gets the toothpaste with brand X and the other one doesn't. Compare the results, right? So I'm just going to say subjects will be randomly, this is a really important word, randomly divided into two groups. Okay. I will say, make that a period. One will get the toothpaste. One will get the toothpaste with ingredient X. The other will get regular toothpaste. Okay, and then what? And then I would just say, compare the results. Okay, that's how you're making your controlled experiment. If at the end of the study the researchers observed a significant difference in whitening, could they conclude that ingredient X caused the change in whitening? Yes, right? Experiments give evidence for cause and effect. As easy as that. Yes. Since this is an experiment, experiments give evidence for cause and effect. Okay? Okay. In number 6, it says, which statement about statistical analysis is false? So, false. Okay? So, what does it say? Experiments can suggest patterns and relationships in data. Sounds good. Experiments can determine cause and effect relationships. We just said that, yes. Observational studies can determine cause and effect. Can observational studies determine cause and effect relationships? No. This has got to be it, because these two are definitely yes and yes. Observational studies can suggest patterns and relationships in data. Yes, they can, but they cannot determine cause and effect. Okay, so you have a little summary here, some things to look for. Remember your observational studies, observe only, no treatment, good patterns and relationships. Participants might be randomly selected. You will see, observational surveys could include surveys, research, clipboard, watch and record, where experiments, treatments imposed, good for cause and effect, they're randomly selected and assigned to treatments, and you have a control, a placebo, and you compare your groups. Okay, so I'm going to let you guys try, let's see how many, about 6 homework questions, and you send it back to me whenever you're done. Hope you guys are well. Talk to you soon.